about logical reasoning. So we're going to read this logic problem, and I'm going to show you how to fill in the chart. I won't finish it for you, but we will definitely start it. So the first example says Millie, Jenny, and Bob and Fred attend 4 different schools, and each plays a different sport. The schools are Berkner, Richardson, Pierce, and Lake Highlands. The sports are basketball, field hockey, football, and volleyball. Determines who plays what, where. Well, the first thing you're going to do is on the top, go ahead and write each person's name. So we have, well, something. From here, you're going to write the school names down the side. Now, you're going to put each sport both on the right side of the names and below the schools. So once you have all the parts labeled, now you can come back and start reading through the clues. So it tells us the girls do not play football. So you know that Millie's not going to play football. Jenny's not going to play football. And then the football player does not go to Berkner. So we can come down here. Football player is not going to go to Berkner. So that also means, well, Millie and Jenny could still go to Berkner. Then it tells you Fred does not play football. So we can come down here and Fred, he does not play football, which means that we know Bob plays football. So Bob is your football player. Now, if Bob plays football, he doesn't play field hockey, he doesn't play basketball, he doesn't play volleyball. Okay? Also, if the football player does not go to Berkner, then we know that since Bob is the football player, Bob does not go to Berkner. Now it says the volleyball player does not go to Lake Highlands. So, the volleyball player does not go to Lake Highlands. The field hockey player does not go to Richardson. So under Richardson, we know it's not the field hockey player. And Bob goes to Richardson. Well, if we know that Bob goes to Richardson, then Bob does not go to Pierce or Lake Highlands, and Millie, Jenny, and Fred don't go to Richardson. Okay? If Bob goes to Richardson and Bob plays football, then we know that the football player goes to Richardson. So the basketball player and the volleyball player don't go to Richardson, and the football player doesn't go to Pierce or Lake Highlands. Okay? From here, you know that Jenny's cousin plays basketball at Pierce. Well, that means that Jenny does not go to Pierce, and Jenny does not play basketball because her cousin does. Okay, we also know that the basketball player is at Pierce, so under Pierce we know that's the basketball player. And so the field hockey player and the volleyball player don't go to Pierce, and the basketball player doesn't go to Lake Highlands or Berkner. So we now know that the field hockey player goes to Lake Highlands. Therefore, they don't go to Berkner. The volleyball player goes to Berkner. Okay? So now we know that Bob goes to Richardson, which we had kind of already figured that one out. And you can go from here and finish the rest of the puzzle. Now, for the next one, we have a Sudoku puzzle. So on a Sudoku, numbers 1 through 10 have to go up and down, side to side, and across the middle diagonals. So, and they're all in each square. So this one's kind of hard to see, but each square has all the numbers 1 through 10. So if I were to bold these. So now what I do on a Sudoku is I look at the ones that I know most of first. So I can see in this square, 1, 2, and 3 are already taken. Okay, so I need a 4, 5, 6, 8, and a 4, 5, 6, 8, and that's all. So I can see there's already an 8 in this row, so this row cannot have an 8. There's also already an 8 here, so this row cannot have an 8. So we know that the 8 has to be right there. Okay? Now, I see there's already a 5 in this row, so 5 can only go here or here. And I put it small in the corner to let me know that those are my two options. 4. Right now, a 4 can go any of these places. And a 6 cannot go here, but it can go in either one of those. So, based on this, I don't have enough information to fill in the rest of it, so I come over to this row. Well, this one, I need a 1, but there's already a 1 in that row, so it can't be here. And there's already a 1 here in this column, so it can't be here. So I know my 1 has to go here or here. My 2, a 2 can't go here because I already have a 2 right there. And a 2 can't go here. And I have a 2 down here, which leaves this as my only spot for a 2, which means if 1s can only go here and here, this one has to be a 1. Okay? Then I need a 3. Well, a 3 can't go here because I have one right there. A 3 can't go there. That doesn't really help me at all. And a 3 can't go there. So I know that my 3 has to go here or here. 4, I don't have any information on a 4 yet. 5, a 5 can't go here because of this one right there. So we have either a 5 there or a 5 there. Now let's come down to this box. This one's pretty full already. So I already have a 1. My 2s can't go here. My 2s can't go here, but I could have a 2 here or here. I already have a 3, a 4, 5s. Well, 5s can't go here. So my 5 has to be here or here. I already have a 6. 7s. I have a 7 right there, so a 7 can't go here. So a 7 is either going to be here, here, or there. And an 8. Well, my 8s can't go here, and they can't go here. So my 8 has to go here and here. Well, now we see this square right here. The only thing that can go there is a 2. So this one has to be my 2. So that means this one are done. And then I don't know enough about the 8, 7, or 5. So you're going to go from here and do all the squares until you can eliminate and get one number in each square. Okay? So you may finish this one on your own.